Launched 3 years before the new century, a spacecraft wound its way through the empty reaches of the solar system. On Earth, its progress was little noted, as it swung twice by the planet Venus, then our Moon, and Earth, the asteroid belt, and Jupiter. Almost 7 years later, on the 1st of July 2004, the Cassini probe entered the orbit of Saturn. It then began to compile what has become one of the greatest photographic collections of all time, of a giant gas planet surrounded by colorful rings, guarded by a diverse collection of moons, and millions of tiny moonlets. Within this record is a trail of clues pointing to the energy sources and complex chemistry needed to spawn life. What are these mysterious worlds telling us about the universe and Earth? In the outer reaches of the solar system, 1.5 billion kilometers from the Sun, there is a little world known as Enceladus. Nearly all of the sunlight that strikes its icy surface is reflected back into space, making it one of the brightest objects in the solar system. At its equator, the average temperature is minus 198 degrees Celsius. It can rise about 70 degrees higher in grooves that stretch across the South Pole like tiger stripes. Looming over it is the giant planet Saturn. In myth, Saturn, the Roman name for the primal Greek god Kronos, was the youngest son of Gaia, or Earth, and Uranus, Sky. Wielding a scythe provided by his mother, the story goes, Saturn confronted his abusive father, castrating him. The blood of Uranus flowed into the seas, fertilizing the Earth, and giving rise to Enceladus and other giant offspring. Saturn's moon Enceladus has its own tangled story. In 2005, the Cassini spacecraft spotted plumes of water vapor shooting out into space from several locations near its south pole. More recent close encounters have revealed jets of water, flavored by slightly salty chemical compounds, spewing out from vents in the rough, cracked polar terrain. That may mean that Enceladus harbors a remarkable secret below its frigid surface. A liquid ocean, and perhaps a chemical environment that could spawn simple life forms. It's not the only promising stop in the realm of Saturn. The moon Titan is often said to resemble Earth in its early days. It is lined with volcanoes and a hazy atmosphere rich in organic compounds. While Enceladus is the size of Great Britain, Titan is 10 times larger, 50% larger than our moon, and the second largest moon in the solar system. We've known about Titan since the astronomer Christian Huygens discovered it in 1655. And Enceladus, since William Herschel spotted it in August 1789, just after the start of the French Revolution. Scientists began to investigate these moons in earnest with the launch of the two Voyager spacecraft in 1977. The lineup of outer planets in the solar system allowed the spacecraft to fly past each of them. Along the way, they sent back tens of thousands of images of planetary realms more diverse than anyone had imagined. These long-distance marathon flyers, both now headed out toward interstellar space, made discoveries about the chemical environments that have turned these planets into gigantic works of abstract art. They also disclosed new details about their magnetic fields, atmospheres, ring systems, and inner cores. But what really turned heads were the varied shapes and surfaces of their moons. They've all been pummeled over the millennia by wayward asteroids and comets. A few appear to be sculpted by forces below their surfaces. Neptune's largest moon, Triton, has few craters. It's marked with circular depressions bounded by rugged ridges. There are also grooves and folds that stretch for dozens of miles, a sign of fracturing and deforming. Triton has geysers too, shooting some 5 miles above the surface. But on this frigid moon, so far from the sun, the liquid that spouts is not water, but nitrogen. Tiny Miranda, one of 27 known moons that orbit Uranus, wears a jumbled skin that's been shaped and reshaped by forces within. Jupiter's moon Io, orbiting perilously close to the giant planet, is literally turning itself inside out. Rivers of lava roll down from open craters that erupt like fountains. What's causing these tiny moons to come to life? The surface of Jupiter's moon Europa offers a window into the churning activity at its core. Flying by Europa, Voyager documented a complex network of crisscrossing grooves and ridges. In the 1990s, the Galileo spacecraft went back to get a closer look. It found that Europa's surface is a crazy quilt of fractured plates, cliff faces, and gullies, amid long grooves like a network of superhighways. How did it get like this? Europa orbits Jupiter in a slight ellipse, diving in close before swinging wide. That allows the massive planet's gravity to constantly tug at its rocky center. The friction of rock rubbing on rock causes that core to heat up. Then, heat rising up through a subsurface ocean of liquid water cracks and shifts and spreads the icy surface in 1,000 different ways. Europa's neighbors, Callisto and Ganymede, show similar features, suggesting they too may have liquid oceans below their surfaces. Crossing outward to Saturn, Voyager found a similar surface on the moon Enceladus. So when the Cassini spacecraft arrived in 2004, it came looking for answers to a range of burning questions. If this moon and others have subsurface oceans, do they also have the ability to cook up and support life? And what could they tell us about the origin of life throughout the galaxy? Cassini came equipped with 12 separate instruments to analyze light waves, the composition of dust, magnetic fields, and more. After a year in orbit, Cassini let go of its traveling companion, the Huygens probe, and sent it parachuting down to the surface of Titan. Unexpected crosswinds buffeted Huygens' parachute, but the probe was able to snatch a wealth of revealing information. Its onboard radar showed a complex topography with ridges, rivers, and lakes, and even rocks on the ground. Titan's atmosphere is thick and cold. Like Earth, the air here is mostly nitrogen gas. What's more, Titan's muddy, wet terrain is laced with organic compounds. On our planet, it's water that cycles from ice to steam. On Titan, it's methane. Methane gurgles up from the ground in liquid form and flows into lakes. It freezes in spots or floats off as gas in orange clouds. This image shows a flash of sunlight reflecting off a sprawling 400,000 square kilometer lake known as Kraken Mare. Scientists consider Titan to be a possible mirror of Earth in its early days, with the chemistry of life still in its earliest stages. That's why they are so eager to explore its varied landscapes. So far, radar passes by Cassini have revealed expansive dune fields, wetlands, hilly terrain, and the occasional crater. Scientists mapped an area near Titan's south pole called Circumlabyrinthus. The image shows a network of canyons and cliffs sculpted by liquid methane. Nearby, methane flows into a lake called Ontario Lacus. A little smaller than Lake Michigan, it's bounded by bays, river deltas, beaches, and other familiar features. And here, in a region called Sotra Facula, Cassini mapped what looks like a volcano. 1,000-meter high peaks tower over craters that are 1,500 meters deep. Are these features the result of an internal heat source, like the grooves that line Enceladus and Europa? Or is Titan's story unique? Cassini has been sending a stream of images and data across nearly 1.5 billion kilometers to Earth. It has been able to draw an impressive portrait of a ringed planet, a turbulent gas giant. Cassini's sensors captured a storm that raged across Saturn's southern hemisphere for months, generating lightning strikes thousands of times more powerful than those on Earth. They documented a giant cyclone spinning around at Saturn's south pole. Its eye is so big, you could drop the entire continental United States into it without touching the cloud walls. Cassini radioed back unprecedented new details of Saturn's most famous feature, its rings. In the year 1610, the Italian astronomer Galileo Galilei discovered these broad, flat, concentric bands. But he didn't realize they were actually rings, nor had he any clue how intricate they are, or where they came from. Until recently, the reigning theory held that the rings were made up of debris from a small moon destroyed in a collision. But they are now known to be 99.9% water ice. How it got there seems to reach back again to Greek myth. Fearing vengeance from the offspring of Uranus, Saturn began to savagely devour the young Titan offspring. The youngest, Zeus, escaped unharmed, and later on would lead an insurrection by the Olympian gods. A recent study suggests that Saturn's rings formed when the planet swallowed one of its moons. In the process, its gravity stripped the moon of its icy surface, which remained in orbit and spread out to form the rings. And from the rings, smaller ice moons like Enceladus took shape. The Hubble Space Telescope showed that Saturn's rings stretch more than 240,000 kilometers across. Yet in some places they are as little as 10 meters thick. If you were to shrink Saturn down to the size of a basketball, the rings would be about 1/250th the thickness of a human hair. Around Saturn, everything acts upon everything else. Moons and countless tiny moonlets pull and tug on ring particles, shaping and twisting and clearing lanes in a dance of twilight moons. The medium-sized moon Mimas, orbiting close in to Saturn, has hollowed out a large gap called the Cassini division. Some tiny moons ride within the rings. Prometheus and Pandora actually hold the F-ring in line. And across the ring plane, spokes of different colored dust occasionally cling like strands of hair on a cold, dry day. Like the rings, Saturn's moons each tell a different story, drawing us in for a closer look. There's dense little Dione, hard rock covered with ice, pummeled on one side by asteroids that left a system of craggy cliff faces. Hyperion looks like a sponge. It's an oddly shaped world that tumbles chaotically. Iapetus, with one hemisphere brighter than snow and the other darker than tar. A strange ridge, like the spine of a rhino, runs around its equator. It's the moons Titan and Enceladus that continue to steal the show. Compared to many of its sister moons, Enceladus has fewer craters. Even the largest is relatively small, only 35 kilometers across. Like Europa, its landscape is fractured and wrinkled, a sign that it's constantly being reshaped by geologic activity. Enceladus lies outside of Saturn's bright inner rings, in the wide and diffuse E-ring. With Cassini's camera pointed at just the right angle to the Sun, the E-ring lit up. Enceladus is the bright object in the center of the frame. What is all this hazy material made of? Could it be coming from the Moon itself? The Cassini science team suspected that they were onto something big. So they went to work, plotting new orbital paths, building a new target list, and preparing to pay Enceladus a visit. They set the spacecraft on course for a series of close flybys of its south pole, down to about 25 kilometers above its surface. This is what Cassini saw. Plumes of vapor rising out of the ice. Scientists began to think of them as geysers, much like those in geologic hotspots on Earth. If the team could find out what these jets are made of, they might just have some clues to what's going on below the surface. Flying through the E-ring, Cassini sampled particles within it. It found crystals of water, and within them, it detected the presence of a compound well known on Earth: salt. Salt dissolved in water is evidence that friction from a rocky core, jostled by Saturn's gravity, warms a reservoir of liquid water below the icy surface of Enceladus. Another fly-through found water molecules that are negatively charged. On Earth, that's a product of waves smashing a shoreline or water flowing over a waterfall. And there's even more to get excited about. The plumes were found to contain nitrogen, likely given off by ammonia heated to nearly 600 degrees Celsius. Here's a diagram illustrating the possible setup. Powering the geysers is an underground reservoir, heated and pressurized by an internal heat source. Close-in observations of Enceladus show the disfiguring effect of all this activity on its south pole. How amazing that even out here, about 9.5 times the distance between Earth and the Sun, this frozen little moon might just harbor the conditions needed to turn chemistry into biology. If Enceladus holds its secrets in, those of Titan are written on its surface. Scientists fed data from Cassini's radar instrument into computer models designed to explore the relationship between its surface and its interior. Their findings suggested that Titan's interior has been steadily cooling. That has caused the moon to shrink and its surface to wrinkle into a pattern of ridges and valleys. In addition, a recent NASA study found little evidence that an internal heat source is currently shaping Titan's surface. The study found that most of its features can be explained by impacts or by this moon's surprisingly active weather. For 8 years, astronomers at the Gemini telescope in Hawaii had been monitoring infrared light streaming in from the Saturn system. For the first time on Titan, they saw evidence of a massive storm erupting over what's thought to be a vast equatorial desert. Cassini has picked up clouds swirling above large methane lakes and seas on the North Pole, and now along the equator in the large cloud formation to the left. Notice the dark regions in the center of the moon. These are thought to be from methane rain drenching the landscape. The clouds likely formed in the recent change of seasons, as the sun began to shine directly down on Titan's equator. It may not be completely crazy to imagine primitive forms of life arising out of this cold, carbon-rich chemistry. One theory is that ultraviolet light from the sun could zap nitrogen molecules in the atmosphere, creating a kind of organic smog that could settle into volcanically active places along the surface and develop from there. Meanwhile, Cassini keeps adding to its historic collection of data and images. With Saturn moving into its farthest point from the Sun, its rings lay flat on the plane of the solar system. The angle of the light allowed objects to cast long shadows across the rings, like this little moon, never before seen, or these moons that seem to have punched through the F-ring. Cassini completed its primary mission back in 2008. Based on all its successes, it's now set to keep padding its amazing record until at least the year 2017. At this point, no one can say whether Saturn's moons have ignited the spark of life. They have certainly ignited our imaginations.